Hello students, in this video we'll see an example of computing an infinite product as a function of z. Let's compute the product, n goes from 0 to infinity, of 1 plus z to the power 2n. In fact, what we're going to show is we're going to find an explicit formula for this. We're going to show this product converges. It's going to converge to 1 over 1 minus z if the modulus of z is less than 1. So let's prove this formula over here. Okay, so let's look at the partial products. The partial products are going to be p sub n, and that's going to be the product. K goes from 0 up to n of 1 plus z to the power 2 to the power k. And let's look at some simple examples of this. So the first example we're going to have is just p1. So p1 is just going to be, when I plug in 1 to this formula, I'm just going to have the product from 0 up to 1. So I'm going to have a 1 plus z to the power of 2 to the power 0 is just going to be a 2 to the power 0 is going to be a 1. So that first term is just going to be 1 plus z. That's when k is equal to 0. And when k is equal to 1, we're going to have what? When k is equal to 1, we're going to have 1 plus z squared, for example. And so this will be a total of 1 plus z squared plus z cubed. And so what we see over here is this is going to be, let's look at P2 for example. So what will P2 be? P2 is going to be 1 plus z, and then 1 plus z squared, and then 1 plus z when n is equal, when k is equal to, when n is equal to 2 over here in this formula, k can go from 0 up to 2. And when k is equal to 2, we're going to have a factor of 4 over here. We know what these things are by induction. Those things are just going to be 1 plus z squared plus z cubed, and then 1 plus z to the 4th, right? And so we see that that's exactly equal to 1 plus z plus all the way up to z to the power 7 over here. So that's a z to the power 7. Good. Z to the power 7. Okay. And so now we can start to see the formula over here. So what's the relationship over here? Well, this is what? This power over here is going to be 2 squared minus 1. And this is going to be 2 cubed minus 1. So it looks like P1 is going to be 1 plus z plus all the way up to z to what power? Z to the power 2 squared minus 1. Looks like P2 is going to be 1 plus z plus all the way up to z to what power? 2 cubed minus 1. And so that gives us a conjecture for what Pn should be. So our conjecture here is that Pn is going to be what? Is going to be 1 plus all the way up to what? All the way up to z to the power 2 to the power n plus 1, 2 to the power n plus 1, and then a minus 1. So that's our conjecture for what the partial product is. And so let's validate this formula. So what's P1, for example? So P1, according to this formula, we're going to try to prove this by induction. So that's our claim. Our claim is that this is the case. And so P1, according to this formula, would be 1 plus all the way up to what? All the way up to z to the power 2, and then this is going to be a 2 squared minus 1, which is just z cubed, so 1 plus z squared plus z cubed, and that formula works out, so the base case works out. And so now let's prove it by induction. So let's assume this formula is true. So we assume that star is true, assume that star is true, and then we want to look at Pn plus 1. So what will Pn plus 1 be? So Pn plus 1 is going to be Pn, the previous term, times 1 plus z to what power? When I go up to n, I'm going to have z to the power 2 to the n plus 1. That's the term we have over here. Now we can use the induction hypothesis. So this tells me that Pn plus 1 is equal to what? Is equal to 1 plus all the way down to z to the power 2n plus 1 minus 1 times 1 plus z to the 2n, 2 to the power n plus 1 to the n plus 1, 2 to the n plus 1. Okay. And so what we have, we're going to have these first, the 1's going to multiply and give me all the same terms, right? Z to the 2n plus 1 minus 1. And then the next term over here, this z, the next term will start with a what? The next term will start with a z to the 2n plus 1. So it picks up at the very next term in the sequence and goes all the way down to the very, very last term, which is a what? Which is a z to the power 2n plus 1 plus 2n plus 1 minus 1. And these terms over here, I have a factor of 2n plus 1 in common times 2. So those terms are exactly just 1 plus all the way down to z to the power 2 to the 2n plus 2 minus 1. And we have our induction, we have our star proved by induction. So star is done by induction, proved by induction. And now we've turned our partial product into an infinite series, and we know what this infinite series converges to. It's a geometric progression. So Pn is going to converge to what? So Pn converges to 1 over 1 minus z, provided that z is less than 1 in modulus. So in other words, this infinite product over here converges when z is less than 1 in modulus, and that is the formula. Thank you very much.